Welcome back, everybody. Welcome back to the channel. So today we're going to be talking about how to process a class. In the previous episode, we kind of talked about how to process symbols, and we've gotten our executable set up where we basically allocated all the necessary data that we needed to allocate. So now let's actually look to see how we actually process a class. So to do this, you're going to want to have a character called data class, and that character for my programming language represents 0x2f. And in here, I'm going to basically, so if I scroll up to the top, when we set our current flag, which represents the current token, I check to see if that current token is equal to data class by passing it the current flag. So if that's the case, then what we do is we get the address of the class. So the way it's going to work is we first want to start off by accessing the address, because this is a great way for us to basically make sure that we're actually processing the information correctly. Because as we're processing data in our compiler, if I go to the syntax.odf, if I scroll all the way to the top, we can see here that every single class is added to the executable in the exact order that the class was created in. So we basically, all of these classes, when we're compiling them, they're going to be jumbled up in a very strange order. So by the time we get to actually outputting the executable, we will basically rearrange all of the classes so that it's in an ascending order. And we basically go from 0 to whatever the max class value is. And it goes number by number. So that way, if we're executing this and we get a number past the total amount of classes because we processed the character incorrectly or something, then we'll get an exception, as you can see here. So if I go back, or not an exception, we'll just return false or return corrupt file. So if the address is greater than or equal to the manifest.classes, then we say file whatever may be corrupt, and I return a corrupt file. Now, it is entirely possible that we could theoretically process a class twice by accident if we have our executable built in an incorrect manner. This is why it's extremely important when you're building your executable to make sure that you are aligning those characters perfectly, because if you don't, it can, like I said, be very catastrophic. So just want to make sure you do that. But once we do that, then we basically get the address of that class by getting the address of vm.classes at whatever the address is. I should also probably check to see if address is less than 0. So I'm going to say or address, address is less than 0. Because of course you could have a 0 address class, so but if it's less than 0, which is that possible? Yeah. So if it's less than 0, then we want to basically have this error as well. Now, I've thoroughly tested my executable, and I've been writing code in Sharp for several months, so this isn't an issue for my compiler, but this might be something you want to do. So what we want to do is we want to initialize the class. I think I went over this before, but basically initialize just initializes all of the class's variables. So if we go back, let's see. So what we want to do is we want to set the address of the class equal to the address that we passed in. Then you want to set address equal to the next get I32. So we're going to get the next 4 bytes of characters in our executable, and that's going to represent an address of the owner. So the way it's going to work is we're going to start out by having the address of the class, then the owner, so who owns the class, and then what's the superclass of that class. So again, if you remember, ownership and inheritance are two different things, so these are those individual values. And by default, so with my executable, I have a standard where if I pass -1 as a value, then it basically means that there isn't a value present. So if our address is equal to -1, that means that it does not have an owner, which is entirely possible, right? Because if we go back to our syntax, if I scroll all the way to the top level class of SRT Global does not have an owner because it's the top level class. So that's entirely possible. And then as we kind of go through and process our superclasses for all of our classes, it's also possible that a class just doesn't inherit another class. Now, after that, we want to go through and pretty much I use get I32 for all of these because, of course, our GUID is going to be most likely more than 4 characters. So it's going to be greater than 9,999. So I use get I32 to save size in memory. So you want to set the GUID, you want to set the name by getting a string from the buffer. You want to set the full name of the class, how many static fields does it have, how many instance fields, And then you want to set the total field count equal to how many static fields plus how many instance fields that the actual class has. You want to get the method count and the interface count. And then we want to do a couple of checks. So if the total field count is greater than 0, we want to allocate the fields equal to the amount of fields for that class. If we have methods, we do the same thing. If we have any interfaces, we also do the same thing. And again, as I've mentioned this before, please make sure that your methods and your interfaces are both pointers, not pointers. Because if it's a pointer, that means it's going to reference another method object in our executable. Otherwise, if it's a pointer like field, that means we have to create and allocate and assign data to that object. So just keep that in mind. So now we get down to processing other data in our class. So we're going to start out by processing our fields, and then we're going to move on to methods and interfaces. So in our executable, we're going to have a number called items processed. And the items process is going to be basically a basic count for us to keep track of how many items that we've processed in the executable. So what we do is I have an infinite for loop here. And in there, I basically check to see if the buffer at the current position is equal to data field. And that character represents 0x22. So if the current character is 0x22, that means that we have a field to process. Then what I do is I check to see if items processed is greater than or equal to the total field count. If so, that means we've processed too many fields in our programming language and we want to say that the file may be corrupt. And then we return a corrupt file. Otherwise, we continue on. So we say current position plus plus to increment the current position. And if you notice, I don't automatically plus plus current position here because I need to check to see what type of data we are processing. So if the current token at current position is equal to a data field, we can handle it. Otherwise, if it's equal to 0x0, 0xa, or 0xd, then we ignore it and then we plus plus it at the end of the for loop. So then I basically get the pointer to the field. So I say and classes at fields, items processed, and I basically at how many total items we've processed. And then I initialize the field by calling the init function, which just sets up the field in its basic values. So if I go back, so for field, we want to set up various different things. We want to basically set the name of the field, the full name, the address, the type of the field, and we cast this I32 to a data type. We want to get the GUID, how many flags or any flags that the field may have, whether or not it's an array, whether or not it's a thread local. So if the current token is equal to a 1, it's an array or it's a thread local. I also have the utype by calling the get symbol function, which, as we talked about before, we basically pass in the file buffer and we basically try to figure out what symbol we need to process. And then finally, we need to set the owner of the field. So who owns the actual field? Now, honestly, this is kind of stupid. You could probably save space or size in your executable by not doing this because we know what the owner is. Literally, the owner is right here. It's inside of this class, right? So we don't really need to access or process the actual owner of that class. We can just set it to that value, but that's what I did. So you guys can leave that out if you want and just set it to class above. That would just make your executable a lot smaller. After that, we want to check to see if the field's utype is equal to null because it's possible that when we're processing a utype, we could potentially return a null here because we found an invalid type in the symbol table. So if that's the case, then we want to just return a corrupt file. After that, we have our standard ignore characters, so 0x0, 0xa, and 0xd. Otherwise, if it's none of these, right? So if it's not a data field, if it's not any of these values, then we basically break out of this infinite for loop. Otherwise, if it is one of these values, then we just plus plus the current position and keep going on from there. Now, once we get down to here, once we break out of this infinite for loop, this is basically the end of it. We want to check to make sure that we've processed all the total amount of fields in that class. So it has to be exactly the same amount of fields in the class in order for this to be assumed to be successfully processed. So if the items processed or the fields that we've processed is not equal to the total field count, then we want to say fail to process all class fields in executable and return a corrupt file. For method, we want to kind of do the same thing. We want to reset our items processed to 0, check to see if we have any methods by checking if method count is not equal to 0. And for this one, we have a token or a character of data underscore method. which represents 0x for C. And for that one, we just basically do our basic check here. So if we've gone over the total method count, we have a corrupt file. Otherwise, for methods, it's pretty simple. So the way that I do it for classes is basically methods are just going to be a pointer to another method in the virtual machine. So basically this pointer array is going to reference data that's going to be residing in the VM. So if I go to virtual machine.h, it's going to be referencing methods that are created inside of the methods array. So if we go back to the executable, we can see here that all we do is say methods at items process plus plus is equal to a reference of methods at whatever the address is. So after that, otherwise we ignore our basic standard characters, and otherwise we break. So if it's neither of these values, we break out this infinite for loop. Otherwise, if it's not, we plus plus, and we do our check to make sure that we've processed all methods successfully. We do the same thing for interface as well. I don't think I have to go over this. You guys get the point. For interfaces, it's kind of the same thing. I just have a pointer of classes. So I just pass the interface at items process plus plus equal to a reference at classes at whatever the array value is. And same stuff down here. Finally, we have a EOS. So for the end of section, that is character 0x1d. So that token is specifically used to specify that this is the end of this section of code that we're processing in our executable. So if we reach that part, then we break out of this for loop. I think this is a for loop, right? Yeah, so it's an infinite for loop. So we break out of the infinite for loop. So if that's the case, then we break out of the switch statement and we check to see if the current flag is equal to end of section. If so, then we break out of this infinite for loop. If I scroll up to the top, we're now finished with processing the, what is this called? The symbol section of the executable. Now, this video, I think we can kind of go into what's after this. So it's pretty quick. We have two more sections that we can go over. So we can go over the string section and we can go over the constant section. So first, let's talk about the string section. So if I go over to my syntax.odf, as you can see here, I have in my ODF file or object dump file, I have a strings section here where I have all the various different strings in my executable. So you can see, I mean, these are just a bunch of random different values and they all have their own addresses. I also have a constant table here which lists out all the constants that I have in my executable. So, and we'll talk about constants in a little bit, but let's look at strings first. So if we go to strings, to process a string section, we want to reset our item's processed value. We want to do our section validation check to make sure that we are in fact in the string section. So if the current token is not equal to section string, and that value is 0x02. So if the current token is not equal to that, then I say file may be corrupt, and I return a corrupt file. Now for the string section, as you can see, it fits on the entire screen. It's fairly short. We just get the current flag, we have our standard ignore values, and then we say case. And by the way, if any of you guys are wondering why I have these, this is kind of hangover code from the first ever iteration of my executable. I had a bunch of zeros and I had these 0xa and 0xd characters in there as like a filler to kind of spread out things and like align data properly. I don't really use that too much anymore, but I kind of kept the tradition, so that's what that is. You guys don't need to have these filler characters if you don't want them. It's not necessary for the processing of the executable because I have a pretty tight system. Before, I didn't really have a good system for processing numbers. But once I created the 4-byte system to process and build a 32-bit integer, this stuff kind of wasn't really necessary anymore. So yeah, but anyway, for a data string, so if the current character is equal to data string, which is a character of 0x1e, if it's that value, then we want to process our string. So we want to make sure that if our items processed is greater than or equal to the total strings, of course, it's a corrupt file. Otherwise, if we have our string, we initialize it by initializing the native string value by setting the length and the chars to null. And then I say strings is equal to, and then I get a string from the buffer. Now, what's different this time is we've seen get string before being called. Where is it? Where's an example? Like right here. So for the full name, I call get string and I just pass the buffer. But the string section is completely different. What I do is I pass a get I32 to the get string function, And if we go to the getString function, that represents the length of the string. So when it comes to strings in the string section, the user can easily corrupt my executable if they just put some weird characters in there. So I want the user to have 100% free reign on what data they can pass into a string. So in order to do that successfully, I basically pass the size so it doesn't corrupt the file. Now, after we've processed our data string, if we run into a character of end of section, we break out of this switch statement here, and then we do our checks down here. And of course, if it's anything other than these values, we say corrupt file. If the current flag is an end of section, then we want to do our validation check to make sure that we have processed exactly the amount of strings that we were told in the manifest. Now for constants. So I want to speak on constants really quick before we just get right into it, because constants are just as simple as processing strings. But the difference is that I've mentioned this before. So if I go to my compiler.h, where's that at? Yeah, it's in the lib grammar backend. If I scroll all the way down to the very bottom, we can see here that we have a bunch of different limits, right? So I have what's called, where is it, a constant limit of CA2 max. And what that represents is this hex value. I don't remember what that stands for. What is it, 200,000? Yeah, so it's 262,143. So plus or minus 262,143 is going to represent the minimum and maximum value of our specific instruction class. And specifically for dealing with constants, they are typically using the class C instruction as a way to gain access to the constant section. So this does not mean that we have a maximum value of 262 constants in our programming language. I don't want you to think that, right? So if I go to my syntax, and as you can see, I have like this return 4, right? If I go to the executable of syntax.odf, 4 is not in this value. What the constant table is it represents mostly really large numbers, meaning numbers bigger than an int 32 or numbers that are decimals. So yeah, just keep that in mind. It does not represent all literals in the programming language. You can have an infinite amount of literals. And from my experience, I don't really write too many floating point numbers in a single program. And honestly, if you have more than 200,000 floating point numbers, I mean that's a pretty large number for me. I can of course increase it if I want to. I just have to change the instruction class and switch some stuff around, but this is what I have. So let's go to the executable. So for this one, what we do is I reset the items processed. I do my section validation for s constant, which represents a character of 0x2, and I already added the constant section, so I don't need that to do. So if, wait a minute. The string section is also 0x2. Okay, well I'm gonna have to change that. That's definitely, that must have been a copy paste error. But yeah, so that definitely needs to change. So you guys can pick whatever number you want. Just again, remember you don't want it to match any other character in your define statements. Now the reason why it works is because the string section is before the constant section. So the fact they have the same value for the character that starts that section doesn't really matter here, but I like to have things different in every section. So for this one, what I do is standard crap. Everything here is the same. I do my check at the end. I do my end of section, my default, my ignore flags. The only thing that's different is in the constant section. So what this represents a array of doubles. So that was created above when we allocated all of our data up here. So as you can see, we created how many constants we needed. So for the constant section, I basically set that double equal to string to double. So I get a string based on whatever the value is from the executable. So literally the values that you're seeing here that are passed, where was it at? So if I go here, the values that you're seeing here are exactly the values that are inside of the executable. In fact, I think I can actually go to the executable. We can actually see it. I have no idea where it is. I'm not even going to try to look. But yeah, these are in fact in the executable somewhere, and we just use string to double to process it. So that's it for that, and that's pretty much it. So now we're kind of almost at the home stretch. So we literally have two more sections left, the data section and the metadata section. So That's going to be pretty much it for today, guys. Hope you enjoyed the video. As usual, if you have any questions, as always, put them in the comment section below. And as always, if you guys would love to help support the channel, you can always head over to the GitHub repository at andrewdevcd/sharp. When you do, definitely watch, star, and fork this repository. That gives this language a lot more visibility and let other developers know this language exists. Also, before I do my standard intro, I'm actually going to switch this up and just do it a little bit different. I'm going to put my closing comments at the beginning before I actually close out the video. If you guys are curious, I'm actually going to be making some pretty big changes to the way I do things with the language. So I don't know when I'm going to be able to do this. It's going to take me a little bit of time to get it together, but I see that GitHub has this thing called projects, and I actually really like it. It's really cool. So eventually what I plan to do is create a project for Sharp where you can actually see in real time what the progress of the actual programming language is. And it's going to be a really nice board structure. Like if I go to learn more, like you can see down here, it has like boards of stuff that I'm doing, stuff that's in progress, and stuff that's already done. It's really cool, so I really like it. So I definitely plan on doing that to make kind of understanding what's going on a little bit easier. Also, if you guys are curious, I did mention before in a previous video that I'm working on a drone project for the Sharp programming language. And if some of you guys are curious about that project and you want to kind of stay up to date with what's going on, it's fairly new right now. There's not really much going on, but that is I created a repository. It's called Project Dragonfly. This project is basically going to be written from scratch. Everything is going to be done from the ground up. I don't want to use like Ardu Pilot or something like that. I want to write 100% of all the code in both C++ and my language. There's some stuff that I just need to do in C, so I'm going to have to use the Sharp Native Bridge for that. But there's going to be some really cool stuff that's coming out of this. I actually plan on building my own custom-made RC controller, and it's basically going to be a custom-made PCB where I connect a Raspberry Pi Mini, or what is it called, the Raspberry Pi Zero, and I solder that onto a custom PCB, and I put LEDs, and I attach a battery, and add some other cool stuff on there as well to kind of control the drone. So there's going to be a lot of stuff coming out of this project. So I would definitely recommend keeping an eye on this one. This is going to be really cool. So to do my standard intro, if you guys are curious about learning what I do on the programming language, as I mentioned, this is only going to be this way for a short period of time. I'm actually probably going to be removing the docs folder, maybe, I don't know. But in the docs folder, if you guys are curious about what I do, there's two main files. There's a changeless file, which is all the stuff that I've done in the past to the language, and the roadmap file, which is all that, but also stuff that I'm looking to add in the future. By the way, you do want to head over to the remastered branch because that's mostly where I do things. That's where I keep things up to date. Also on the remastered branch, you can also check out the commits in there. I write some pretty decent commits, so you can kind of get a gist of what I've been up to without really having to look too much in the code. Mostly, I've just been trying to get this crap to work. I've had some issues with my Sharp Native Bridge running on the Raspberry Pi, but I think I fixed it, so fingers crossed I don't have any more issues. But that's going to be it for today, guys. As usual, if you're new to the channel, definitely consider subscribing, and until next time, I'll see you guys later.